Hello everyone, this is the 10th lecture of the data science series and the topic is dimension reduction. In the dimension reduction, the first point is demonstrate how will you identify the multicollinearity RPython. Identifying multicollinearity. Multicollinearity occur when the two or more predictors in a regression model are highly correlated, making it difficult to determine the individual effect of each predictor on the response variable. High multicollinearity can lead to unstable coefficient estimate and reduce the interpretability of the model. There are the two common ways to detect multicollinearity. The first is the correlation matrix, and the second is the variance inflation factor VIF. First, correlation matrix. If predictor have the pairwise correlation above a certain their hold, example 0.8 or 0.9, it may indicate multicollinearity. Second is the variance inflation factor VIF. VIF quantifies the extent to which a variable is explained by other predictors. A VIF value greater than 5 or 0 suggests multicollinearity. There are the two common way to detect the multicollinearity. Now, next the second topic is demonstrate how will you apply a principal components analysis using RPython. PCA is a dimensionality reduction technique that transforms the correlated variables into a smaller number of uncorrelated variables called principal components. These components capture the maximum variance in the dataset. PCA is useful when reducing the number of the features while retaining as much variance as possible. Dealing with the multicollinearity since creates orthogonal components. Steps in a PCA. The first step is standardization, second is the covariance matrix, third is the eigen decomposition. Now the fourth is the principal components and the fifth is the projection. Now first is the standardization. Variables are standardized have two mean of a 1 and a variance of mean of a 0 and a variance of 1. Now second step is covariance matrix. Calculate the covariance matrix of the standardized variable. Third is the eigen decomposition. Compute the eigen values and the eigen vectors of the covariance matrix. Now the fourth point is principal component. Eigen vectors with the largest eigen values represent the principal components. Now next point is projection. Project the original data onto the principal components. Let's see some example of the multicollinearity and demonstrate how will you apply the principal component analysis using RPython. Here the example of the identifying multicollinearity using variance inflection factor VIF. First of all, imports panda as PD and imports numpy as NP from state models states outliers influence. Import variance inflation factors from sklearn dataset and import load Boston. These are the methods are applied on the identify multicollinearity. First of all, load the Boston housing dataset. Now second is the add a constant column for the intercept, and the third is the calculate VIF for the each features. Now second example is applying principal components analysis PCA using sklearn. From sklearn decomposition, import PCA. From sklearn dataset, import load IRS, import metaplots.flyplot as PLT and import pandas as PD. In this apply principal PCA using straight-line. The methods are the first of all load the Iris dataset. Our second method is apply PCA to reduce dimension to components, and the third method is the visualize the first two principal components. Let's run this code here. This is the output of this code PCA Iris dataset.